dot dot. All right, now we're going to get that the arg count is 2. And in the first array of arg v, we get a CD, and in the second position, we get the dot dot. Okay? So I would encourage you in lab 6, I put in a section to do this. What would be nice is if I went in and put a /n here so that the prompt would appear a line below these. And I haven't got around to doing that yet. But it kind of proves to you what arg count and arg v actually are and actually do, because we use them a lot in the shell program. All right, so I type exit. Command line was exit, 1 arg count, and the word exit was in position 0, and that's all there is. And we're out of the shell. Okay, let's go look. At lab 6 slides. This has been mounted up in Csc60. So all the system calls that you're going to need in lab 6 are here with a little bit of explanation. Some of it's in the directions too, but there's a little more here if you need it. So you're going to have to do an exit. Obviously I typed exit to get out of the shell, right? Okay. The exit call doesn't return anything, it's a void. And then you do exit, and you pass to it a status. When I see exit parentheses 0, exit parentheses 1, I'll be honest with you, I never can remember which one is which one, which is why I always say exit success or exit failure, and let the system fill the number in for me. And besides that, when you do that, it's documenting. If you don't remember which one is which and you see a 1, you're not sure what it's doing. And besides, in an exit, a 1 means failure. But if you do a while 1, that means true. So 1 doesn't always mean 1. Okay. By the way, exit success and exit failure are defined in standard line. 2 lines in there, found defined. Okay, the next call we're going to need is get CWD, which we are going to use in working with the when we type in PWD for our working path, we'll need to use this system call. You pass it a buffer where it can put the path, and you pass it what the maximum size of the buffer is. And those are set in the code. You can just use those variables. All right, we'll need get env. Some time ago, we ran a little program in here called environ, and it showed what the environment of a process was. Printed off a whole horde of stuff in all kinds of different colors. It showed us what our default shell was, where our default home was, all what the colors were on our terminal, what our terminal type was, all kinds of stuff. So a get env allows you to go out and get individual values from the process environment. So you pass into it a name, and it comes back with a character. So the name that you're going to need to pass in, if you do a CD no dots, need to go up 3 levels, is quotes around the word home. Home is the initial directory into which the user is placed after logging in. And this field becomes the value when you do the home environment variable. All right, another call we're going to need is to change directory, chdir. You have to pass into it a path name, and you get back an integer of success or error. You can pass in a relative path name, which is what happens when you do a cd dot dot. It just moves you up 1 level. but you didn't spell the whole thing out. The absolute path name is when you do the whole thing. Gaia, faculty, Beal, Csc60, my work, lab6. That's an absolute path name. But when you type things like CD ... it just knows to go one level up. All right, those are the system calls you need for lab6. There's not too many of them. So make that go small. And let's go start looking at the directions. Come on, mouse, where did you go? You should start with this program and assignment working on the alternate computers. Those of you who work on your own machine, you can work on your own machine. So if you take it down, it's your problem. Realistically, in lab 6, you're not going to bring the computer down. Okay? You log into Athena, you do an SSH to one of those 4 computers, you type your password in again, you're on one of those alternate computers, but your whole file structure is there because they all share the file system. So it's just like being on Athena, except that if you crash the system, you crash only a few people and not a whole horde. Everybody will be happy if you don't crash the whole horde. Okay, so coming down a little further, we're going to have 3 built-in commands: CD, change directory, PWD, yes?
You can't see.
Oh, thanks for telling me. Okay, so back up, oh, I don't want to do that, I'll stay right here. I want to back up a little bit. Come on. So at the top, we have the purpose of this, and in red, the 4 computer servers that you can use where it's not so catastrophic if you bomb out. All right, move down. You're going to implement 3 built-in commands: change directory, print the working directory, PWD, and exit. But you'll also have to deal with the fact that if they don't issue a command, you reprint the prompt and wait for another chance. Okay, so down we go. Files to copy. I put an extra wrinkle in this time, and that is the capital R. When you do this, it will copy a folder, a directory called lab6 into your directory, wherever you are, and then it will put in it the file that's waiting for you in that folder. Okay? So you should probably be in Computer Science 60, and then it'll create a lab6 folder, and inside of that will be lab6.c. Okay, and just to make sure, what I started doing on these commands is double spacing in between these things so the spaces are pretty apparent. But I've also told you where the spaces go. Okay, moving on. You just do a GCC on this guy. That's all you need to do. So, in main, if the user enters an exit, they've got to terminate. If they enter a CD with a name, you have to figure out what to do. If they enter a PWD, you need to use the getCWD function and print out their full working path name. An additional, you have to deal with the fact that the user might just type an enter key or a space. Now, how do you tell that? Because the arg count will be equal to 0. No command was entered. Let's go back over to this, and we'll bring up the program we just ran that has those little troubleshooting errors in it. All right, if we do a PWD, it tells me where I'm at. do a clear, move up to the top, PWD. All right, now I'm going to hit a space and I'm going to hit the enter key. No command. It tells me that the command line has nothing in it and the arg count is 0. So, how do you know? You say if arg count equals 0, we're going to get out of this loop and go back up to the top. So you'll just do a continue. Easy. Okay, so now back to where we were in the directions. We have pseudocode. The pseudocode for this section is pretty spelled out so that people will dig in and get their feet wet. I'm giving you a week and a half. There's like 25 lines of code at the most. That shouldn't take you terribly long. And the pseudocode is really spelled out. Now, when we get to lab 7, which will build on this, the pseudocode will be a little more generic, but we'll deal with some examples in class and figure out what you have to do. So 6 and 7 are going to be a shell. Lab 8 will be a pipe. Lab 8 will not be part of a shell. We made an executive decision this weekend that trying to incorporate a pipe into the shell would take more complication and more time than we have time left. So we're just going to have a program that's not a shell that you learn how to do a pipe. And I can't imagine how many of you are ever going to have to write a shell out in the real world, but it just gives you the opportunity to do system calls. Okay? So we start with a while equals 0. I think I changed that to say true, and I have a define up at the top. The true is 1. While this is true. It's always going to be true until you skip out. We're going to define a child PID, which we won't need for lab 6, but we will need for lab 7. The command line, we're going to print a prompt. Remember when I was running it, it's in the shell, the prompt changed? You print it.